Now we would focus on a different kind of filter called a Butterworth filter to reduce the noise in the signal present. So, what's the dictionary definition of Butterworth filter? In engineering, we say a Butterworth filter is maximally flat. That means it has no ripple in the pass band and produces zero in the stop band. So it's an ideal filter compared to the k-means moving average filter. So now we are going to discuss the MATLAB code in order to implement the Butterworth filter. You would see over here, we are using the same noisy signal. For those of you who haven't heard the previous signal, let me just play it for you. So this is the original noisy signal.
Author of The Danger Trail, Philip Steele, etc.
As you could hear, the signal has a lot of inbuilt noise in it. So the first step, what we would do is we would try to read that signal. Now, in order to read the signal, we would use the MATLAB code audio read. This is the name of the file, noisy.wave. S is the signal data, as you could see over here. Fs is the sampling frequency, which in our case is 48,000. Now, when you're designing the Butterworth filter, you have to define a cutoff frequency. So we are keeping the cutoff frequency in this case at around 2000. That's around 2 kilohertz. Now the order is what's important. So we would try to keep on changing the order of the filter. This is very similar to the k-means average where we change the value of k. However, in Butterworth filter, we would try to change the order. So let's start with a simple order 2. So once you assign an order to it, you would use the command butter. Now, when the butter is actually an inbuilt function in MATLAB that helps you to build the Butterworth filter. So it takes in the order, which in this case you assign as 2, the cutoff frequency, which you gave over here at around 2k, and you're dividing it by the sampling frequency, half of the sampling frequency. And it's a low pass filter. Now, once you have designed the filters, your next step is to apply the filter. Now, B and A are taken from here because you're designing the Butterworth filter. So the B's and A's are from here, the numerator and denominator, the transfer function. S is the sampling frequency, and you're applying the filter to this one. Now, filter similarly is an inbuilt function. Uh, like you had butter, which was an inbuilt function, filter is an inbuilt function. And once you apply the filter, it's producing the filtered signal. Filtered signal. This is the signal that you're getting. Our original signal was S, which had the signal. Our filtered signal over here contains after you apply the Butterworth filter. Once the Butterworth filter is applied, you're trying to write that signal into another wave file. So we are using audio write. This function audio write command helps you to write whatever the signal that you produce into a wave file. So we are trying to create a filtered output butterworth.wave. This is the wave file that you're creating, and you're creating it to filtered signal and this sampling frequency, keeping the sampling frequency same. Next is you're trying to plot the graph. So you basically need a timeline, and then you basically have the different labels. So in one of them, you're trying to create the original signal, the first plot, and then is the filtered signal using a Butterworth filter. Now let's save it and let's run it. Now you would see over here, this is the original noisy signal, right? However, when you're applying this Butterworth filter of order 2, you're getting a somewhat clearer signal. Now let's listen to this signal. So let's copy this file and let's paste it over here. Now let's play it.
Author of The Danger Trail, Philip Steele, etc.
Now this signal is still not very clear. It does have still some noise in it. So what we can do is we can change the order. How about we change the order to 4? Let's save it. Let's run it. You will see the signal, the filter signal is somewhat more clear, the noise is reduced. Now let's listen to this. So let's copy this file. Let's get rid of the previous file and just replace it. Let's just,
Author of the Danger Trail,
you would,
Philip Steele, etc.
now you would see the noise is gone. So with a higher order, we were able to get rid of the noise. So it's very similar. So the Butterworth filter is somewhat more efficient compared to the K-means average, but both of them can be applied to change the noise, to get rid of the noise in the signal. When it's a K-means averaging, we're trying to change the value of K to get rid of the noise. However, in a Butterworth filter, we're just trying to change the order of the filter to get rid of the noise.